Hello. I'm back now. My internet decided to disconnect itself, but I'm back now. But yeah, I couldn't reconnect to the previous stream, so I made a new stream. Alright, shut up, me. Okay, here we go. Alright, so sorry about that. We are hopefully back. I'll keep a better eye on the internet this time, so I'll know quicker that we've disconnected. As you can see, I've gone through the whole equation without noticing. I checked the VOD for the last one to double check where I actually disconnected. But yeah, so basically I didn't cheat. I absolutely did not cheat. So what I was realizing was that you can separate to 1 plus cotangent squared, and I checked the derivative for cotangent and it turns out to be minus cosecant. So I separated the equation into two parts, one with cotangent, 1 plus cotangent squared, and one with cosecant, and this is what I end up with. Alright, I did it legit, okay? No one can tell me otherwise. Let's go view. Yeah, so my internet it likes to disconnect itself, but what I tend to do is to reset it, I have to run to the actual router, which is not close to where I'm streaming at all. Streaming in my room, which is very far away from probably the opposite corner of the house to where the actual router is. But yeah, it is what it is. I should probably get better internet, but that's technically the best internet they have, so it is what it is. Alright, next one. We have a x times tan square of x dx. One thinking again is to expand tangent, which again I can't remember, so I think let's just write it out just in case I make a mistake again. Right, so we have sine square plus cos square is 1, once again. Define all this by cosine this time. And we have tangent x plus 1 equals to secant squared. So I'm thinking we can do that here, maybe, but then what would that give us? That would be 1 minus secant square x. So we have an x on one side, but on then we also have, I guess, x times secant x. That doesn't really, does that really help? Right, this one seems a bit tricky. Let's see. Is there something I can substitute that will give something on the inside? I guess something like you have an x times a function of x if the x itself is a function of what I mean is, like, if I say if I have something like this could be completely wrong, but if I have something like tangent of u square, if I differentiate this, you would get I don't know why I picked tan square, but it would be a function within the chain rule, basically. So you would first sorry, this is not the chain rule. What's it called? Product? No, not product rule. What's it called? I muted myself. Oh no, I think. Basically, I need help with this. I got a bit. I got part way through this and I can do it. And I decided to roll on the wheel because I need some help. And you can hear my reaction, but. Yeah, because I'm muting myself like an idiot, but basically, yeah, I'm doing 5 sit-ups. I'm so glad there's not plank. Should I stretch beforehand? Can you... I guess you can hurt yourself with the sit-up as well. Do a little stretch. Alright. Alright. Put on the workout music. Alright, 5 sit-ups. One, 2, 3, 4, 5. That's easy. Okay. Whew. I'm really out of shape. Alright. Alright, now that I've done the punishment, let's investigate how we can solve this, alright? So let's have a look on the interweb. I think you know what? I think I'm pretty close there. Ah, I see. I didn't think about that. No, hang on. This is slightly different from what I have. No. Incorrect. I've found a solution to x times tan of x squared instead of x times the tangent square of x. Very different. Okay. Okay. I guess what we need to do is use the product rule for integration. Alright, forgot to turn off the workout music. I'm looking up. There's a video on Black Pen, Red Pen with the exact same thing. I'm just going through it. That's why I'm a bit silent. But I'm not entirely sure what kind of rule he's using. Just because he's doing derivative of something twice. Am I misunderstanding? I've never seen this DI method. Then again, it could just be something that I haven't thought about. Okay, in that case, alright, I'm going to use the products rule, which I'm familiar with. So, let's get rid of this mumbo jumbo. Let's rewrite this as x times to be fair, I kind of needed that previous bit. Bring those back. Alright, so I don't need this bottom bit, so we can get rid of that, but this bit I need. So let me just rewrite this as 1 secant squared of x minus 1, and then we can use the product rule, which I believe I can remember is based on the product rule of the differentiation derivative. So I believe if you have an integral of u times the derivative of v, I can omit the dx here, equal, you will have uv minus the derivative of uv, or something to that effect. I think those are pretty interchangeable. Even if I got that wrong, you can replace v with x. Yeah. So in this case we have u is x, which you can derive, gives you what? V, here, v prime here, we can have secant square of x minus 1. In order to get that, we need to integrate it, and integral. We know the derivative of tangent is secant square, so this gives you tangent of x minus x. Okay, so I guess then this returns to you x times the tangent of x minus x minus, kind of running out of room here, the integral of tan x minus x. So I think we solved the integral of tan x before. Hang on, let me expand these top bits. X square. So I believe this is just the natural log of the minus lateral log of cosine. I believe, yeah. So we plus the natural log of cosine x, and then you have a plus x here, which is just plus x squared over 2, which gives you, simplify that, you get minus x squared over 2, so you have x tangent x plus natural log of cos x minus x square over 2 plus c. Is that what he got, Mr. Red Pen, Black Pen, Red Pen here? Let's see. X tan x minus have x squared plus c times is it? Did I got the tangent of? They got the integral of tangent wrong. Is it actually? I did, didn't I? For the previous one as well. Did I? Yeah, I said it was actually. Hang on. Let me look this up because it will depend if I have to do a punishment or not. Integral of tan. Yeah, I guess minus natural log of cos is equal to the natural log of secant, because you essentially raise it to the power of minus 1. I have plus here, and he has minus the natural log of secant x. They are the same thing. Okay, I am correct. I don't have to do exercise. All right. Okay, we are what, an hour through, and I've barely gotten started with these 100 equations. So let's keep going then. I'll probably stream on another day, but let's see. Let's keep going for now and see how long we can go. So x square, cos x square of dx is the next one. I guess I will use something very similar to before. And just use chain, so cos squared, you can write it as 1 minus sine square. That gives you x square minus x square sine square x. Then well, or x squared times 1 minus sine square x. So then I guess what you can do is use the product rule again, but then you have x squared derivative, that's 2x. On the other hand, you have 1 minus sine x, which turns into x time minus 2 sine x cos x, which is sine of 2x. I don't know. That seems to be to be a bit harder than. What if we x square cos x square, or cos square x, is also x times cos x times cos x squared. Bit confused. Is this going to be a 100 exercise because I cannot solve 100 question? Is that how this is going to go? No, come on, stomach. You can, you absolute idiot. Come on, I can solve this. I can solve this without having to do exercise. All right, I guess I'll have to do another exercise because I'm stupid and dumb and stupid. If you are worried about exam seasons, don't worry. I have. I spelled that wrong, but more. Okay, I have to stretch this time. I can't. Otherwise, I'm gonna pull another muscle. But right, 5 more shrimps. To do some stretches so I don't hurt myself. Alright. Ready? 1, 2, 3, 4, 5. Alright. That felt a little bit better. Alright, now that the punishment's over, we can figure out how to solve this. Go with that. I'm sorry if if this is the worst stream in the world, but it is what it is. Alright, let's figure out how to solve this, alright? Let's do a little search on the web. Alright, let's see what people suggest. This is from... Oh, interesting. I see, so... So, the trick of interest here is to Okay, okay, might be a bit long. I don't even know if I can fit this on one page, but we're using the fact that cos square x is equal to, what was it? Yeah, we're using the definition of cos 2x and using the double angle rule to tell us it is actually 1 plus cos of 2x over 2. Right. Gosh, it's... If you're wondering why I'm struggling, it's been very long since I have to do integrations like these, but you know, I do enjoy them. It's like putting a puzzle together, and the more pieces you know, the more ways to solve a puzzle you know, the funner and the easier it gets. But if you're not a clue, then it does feel like you're just going down a spiral of knowledge. So that we can extract the first bit, because you know that the integral of x squared is just x to the power 3 divided by 3, but don't forget about the 2 at the front there. So 6, and then we're going to have to use, I believe, the product rule again. So in this case, we're gonna have to solve this second bit here. We would want to reduce the amount of x's at the front here, so x square. We're taking x square. Should we include the 2 in it? Yeah, why not? Let's include that. Halved, which the u derivative is 2x over 2, which is just x, and then you have the second half. Oh, that's not right. Which is cosine of 2x. Integral of that would give you, I believe, is half times the sine of 2x. Right? It's yes, because it's integral cos to sine. There's no minuses. So half of sine 2x. So that gives you, again, uv, we do the diagonal first, which is x squared over 4 sine 2x. Oh, sine, that looks like a square. 2x minus the bottom 2 integrated. So integral of x over 2 sine 2x. Now to solve this, we have to use another integral. Let's use a different color just to highlight it. U is x over 2, and we can take that away because it's half, and v, the integral of v is the sine part, and integrate that. Now we have to include the minus of a half, cos 2x. Running a room there, but that's fine. So this gives you x cube over 6 plus x square over 4 sine of 2x, god what a mouthful, minus, no, plus, because there's a minus on this one, this here, plus x over 4 cos of 2x minus, so hang on, minus, there's one minus here, there's one minus here, but then you're also subtracting this, so minus 1 over 4 cos, minus integral of cos of 2x dx, and this is just 1 over 8. So to write the whole thing out is x6 x square over 4 sine of 2x plus x over 4 cos of 2x minus 1 over 8 sine of 2x plus c. Right? Okay. I think that is correct. Alright, so I say let's get to 10, then we can take a little break. Maybe we'll talk, maybe I'll go away for a bit, but yeah, let's get to 10 at least first. Alright, 9. We have integral of x to the power of 5 times the square root of 2 minus x cube. Ooh, I can't write 3 properly on this apparently. Dx. So so what I can see is that x to the 5 is, if I say let x to the cube equals u, derivative u is with respect to x would be 3 times x squared. So therefore x to the 5 is the derivative of u times u over 3. But then you would still have a square root of 2 minus u. So maybe it's better to let u equals square root of 2 minus x. Maybe let's try it. So I'll let u equal 2 minus x cube. So then u square is 2 minus x cube. You realize I have 2 ways of writing 3, but I trained myself to write it in this weird like spiral pattern when I was in high school because I thought it looked cool, but then I just ended up having 2 ways of actually writing it. But yeah, these are both 2's, alright. So then you have 2u du, because you're deriving this side by u, and then deriving this side by x, equals minus 3x squared of dx. So we have dx actually equal minus 2/3 of u over x squared times du. I think that would be correct, because over here you could write this equal to, so let's separate this to x squared times, this would be x cubed, but x cubed is also 2 minus u squared because of this here. So then you have this times u of dx. So then we substitute the derivative with respect to u here. Then we have minus 2 over 3 times u times divided by x squared. So you have 2 minus u squared times u squared du, which is just 2u squared minus u to the 4. So you can solve that fairly easily. So to put that in the front, 2u squared, derivative would be u 2/3 u to the power 3 minus 1/4 u to, no, minus, that's 2 1/5, sorry, u to the 5. Yeah, which then we can go back to the original, which is now minus 4 over 9, 2 minus x cubed to the 3 over 2 plus 2/15 of 2 minus x cubed to the 5 over 2 plus c. I guess I should plus c here as well. Wow, okay. I'm surprised at myself being able to solve that, but that one seemed a bit easier than the other ones to me. Alright, we'll do one more and then we'll take a quick break. Maybe we'll chat, maybe I'll come back and chat a little bit, or maybe I'll go take a physical break, but I don't know how far we can get. Let's aim for, I don't know, what time is it? How long has it been? Like an hour and 2 hours. I don't know, let's aim for maybe 25, 30, you know. It'd be cool if we can get 50 done, but that's going to take maybe a bit long. Alright, so the next one that we have, number 10, is 1 over the square root of x squared plus 4 dx. Now, right off the bat, is this perhaps one of the equations that I could be looking at the top? Because it seems like it could be. Maybe not. Maybe I'm mistaken. So how would one solve this? Let's see. Uh, mm, so effectively that's x squared plus a squared, right? With a being 2 in this case. Let's use something similar to what I did before and progress there. If it doesn't work, I'll backtrack. But what if we start here? What would that get? What will happen there? We can do u squared is x squared plus 4. Then what happens here? This becomes 1 over u, but then we have 2u du equals 2x dx. So dx is u over x times du. So the u will cancel out and now 1 over x left. But what is 1 over x? 1 over x is u squared minus 4 square rooted, which then just brings us to something very similar. So, well, technically u squared minus 4, you can divide that to square root of u minus x, u minus 2, and square root of u plus 2. But I don't think that's an easy thing to solve either. So I don't think this is correct, right? I don't think that counts as a roll spin on the wheel, but because I prefaced that I don't think that will work. So is it really not one of the equations above? I guess not, because it's there's like minuses. So let's see. Could this be one of those equations where you have to substitute this with a trigonometry? I remember some of those equations. Ooh. Alright, I'll do one spin of the wheel and then I'll have a look so that I can actually know how to do these trigonometry substitution in the future. Alright, give me some punishment in exchange for knowledge. Ten squats. 10 squats. That's easy. I can do that with the headphones on. Alright, 10 squats. 10 squats, ready? Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was slightly harder than I thought because my legs were already tired from today. Wowee. Still felt easy. Alright, let's look this up. Alright, I was correct. I see. Wow, okay, that's... You know what, I would never guess something like this, but so what you want to do, yeah, you have to replace x with 2 times tan theta, or yeah, so if we let oh geez, okay, So if we let this like tan of theta equals to say we want 2 of tan so that we can get the squared to be a 4 factor in the front. So 2 tan equals x. We wanted to say, let's say that. So you have x squared equals to 4 tan squared of theta. I still have the workout music. Oops. Thanks for the encouragement. But yeah, so we have x. So in this case, you also want to take the integral, which would be well, we don't have to do it on the x square here, we can just do it on this. So which dx is 2 times the secant squared of theta d theta. That's the substitution we're using, which, God, these are probably the ones I'm least confident in knowing. So we have 2 times secant square of theta d theta over, let's take out the 2 at the front, then tan square of theta plus 1. And we know that this is an identity we can solve. Basically it's the sine square plus cos square equals 1 all over cos square again, which we've done. So this is tan square plus 1 equals cos 1 over cos square, so it's secant. So I say you can see how that clears things out a lot. So this becomes integral of secant squared of theta over secant. So what you have is just just secant, right? Just secant of theta d theta. Now, have we done secant theta before, or is that something we don't know yet? So I don't think we have. Integral of secant. Alright, so integral of secant would, I guess, depend on what derives into secant. Alright, hang on. Let me learn. Let me do some learning. Does this guy mention how? No. So, okay, let's see. I think it is. Right, this step is not super clear because they seem to have a solution for just this integration, but Wow. So you can tell that this is... Wow, I would have never guessed, because this is going to be 1 over cos. So what they are saying is if you multiply this, I'm sure there's probably easier way, but if you multiply this by tan of theta plus secant of theta over itself, so that goes to 1, then you would have the integral of secant theta tan theta plus secant squared theta over tan theta plus secant theta, which, oh gosh, we know the the derivative of tan is secant squared, and let me highlight it. We know that this goes into that when you derive it, and secant goes to secant times tan when you derive it. So therefore you can, similar to the previous natural log, you can let this be the natural log, I guess that needs to be, of tangent theta plus secant of theta. How would you... That is probably one of the harder ones I've encountered. That is quite complicated. There might be an easier way to solve. So obviously this is an over, because we know that tan theta is x over 2, but we need to solve what is secant theta, which, okay, let's do a different color. So we know that tan square theta is x square over 4, and we know this is 1 minus secant square from, oh no, other way around, secant square minus 1. So secant theta is so it's plus 1, so x squared plus 4 over 4 square rooted, so we have the square root of x square plus 4 over 2, and so the final answer here in terms of x is the natural log of x plus square root of x squared plus 4 over 2 plus c. So this step here needs a bit of clarifying to me, because there might be a better way to actually solve this that I'm not too sure of. Hang on, x squared over 2, sorry. Yeah. Oh well, it is what it is. I'm not going to drown on it too much. So that was question 10. I think we should take a little break. And I'll be right back. Go grab a drink or something. Alright, quick break. I'm back. Yeah, so here's the next question. I guess we can just jump right into it, or... But it looks fairly similar to the one before, which is not the most encouraging sign for me. But... you know, I guess it is what it is. But, yeah, so from what I remember on the other guy, you know, I can bring him back up because that doesn't count as cheating. What you can do is you can draw like almost like you can draw a triangle, which I remember doing, but I don't remember exactly the reason why. But so I think what seems to be useful if you draw a triangle and say that's theta. You have on this side x squared plus 25. Then, so that's the longitudinal. We'll have x here, and we're gonna have 5 here, and that's almost like that's a triangle you can use to reference it back to here. So what we can say is that, oh, do I want a different color? Yeah, sure, I'll change it already. So tan theta in this case will be x over 5, right? And we would have dx equal to 5 secant square theta d theta. So on this side we have 25 tangent theta over, together 5 square root 1 plus tangent square theta d theta. No, d, that would be dx, but we want to change it to d theta, so we have to multiply it by 5 secant squared theta d theta. Quick reminder that 1 plus tan square theta we've determined was equal to secant square, so then here we have 25. I could be going on the wrong route again, and I need to substitute with something else like sine or cosine. Let's keep going, and if it's wrong, it's wrong, then we'll figure it out. So tan square, bottom here, secant times secant square, so I'll end up with tan square theta secant, not square theta, d theta. Now, what do we do with this? Alright, so previously we know that the, what was it? The derivative, hang on, I can look this up because I've done it already. The derivative of secant is secant times tangent. And how does that help us here? You might ask, and I would say that's a good question. Maybe we can use products rule. That seems like one of. Alright, so if it's products rule, yeah, we'll let u equals so secant goes to tan secant. So what we have is, if we just take tan here, one sec guys, sorry. And derivative of that, we know secant squared, and derivative of v, we say let's let that as tan secant, maybe there's a story, and that we know is secant. I'm saying these very confident, but I have no trust in my memory whatsoever that these are correct. I think it is correct. So tan gets to secant, secant gets to tan, secant. Not like I know how to actually get this to become something legible at the end, but let's just see how where this goes. If it's incorrect, I'll do some push-up whatever and see what we actually want to do. So we have 25 tan theta secant theta minus the integral of secant cubed. What is the integral of secant cubed? I don't know. Have we done integral secant before? Is that one of the things we've done? Could be. Don't think we did. We did sine secant, which you remember was natural log of cos. Secant we can also write as secant times secant square, which is 1 minus tan again. Can we somehow derive that back into? No, because it's yeah, I don't really have a clue here. Should I do it? I'll do it. I'll do another one. These next, I have a feeling these next few ones is going to be all painful. Alright, bring up the whale. Turn this music off. We need 10 squats. 10 more squats. Alright. Get comfortable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. Ow. Alright, get out of here. Alright, so integral of x squared over square root of x squared plus 25. Good thing about these equations, it's fairly standardized, so a lot of people have solved it on the interwebs. I I was right. I did the so substitution at the start was incorrect already. Yeah, that would have been a lot simpler. So honestly, I have no idea how you would figure this out by your lonesome without just memorizing what situation you would do. I guess there might be some form of some way you can tell from the shape of this what substitution you would want. But instead of tangent, we would want to use sine here instead. Oh no, hang on. This is a different equation. I was like, this is a minus, not a plus. That would explain why it's different. Let's bring this back. Back. There's a video on Black Pen Red Pen on what integration technique should I use. Yeah, I guess if you want to learn, I recommend go check that video out. But for now, I am going to keep just doing from what I know from my brain, because it's funner that way, I guess. And I have to do more exercise. Alright guys, hang in there, hang 10. Let me just... I can't find a good like page on this question, except for one. But no, that's not even right. Wow, is there for some reason no solution here? No one's done this. Okay. Hang on, someone has done x squared over square root of 1 plus x squared, which is very similar to what we have. So, tan over secant times secant. Yep, I've got that far. One over whoa. Something happened there. So somehow I've gotten that part correct. So tangent secant is the front bit, but then I have to add a natural log of tangent plus secant. Is that similar to how I did the previous integral and I'm just being stupid and forgot about it? No, but that was just secant, right? That's the integral of secant, not secant cubed. Half of... I am a bit confused. That's okay. We're all a bit confused. I realize when I'm stuck on things is the content just becomes... Okay, integral of secant. Someone's done integral of secant cubed. We can go from there. Oh dear, it's quite long. Okay, so essentially, from what I understand, secant. Let's use a. I don't have any more colors prepared. Let's use a orange. So, from what I can tell, secant integral of secant cube. I guess at this point for simplicity's sake, I will write it as 1 over c cos cubed, or c cubed, dx is also equals to 1 over c square times 1 over c dx, and this gives, if you use the product rule again, would give you so yeah, it will give you something like 1 over cos times sine over cos minus the integral of sine over cos times sine over cos squared. Anyway, long story short, you would end up with I'll write this as write sine as s, sine over cos squared minus, I know this is kind of cheating, but honestly I'm seeing there must be a better way to do this other than this, but if there isn't, then you know, I've done the punishment. Let's just say I couldn't solve this by myself. Minus the integral of 1 minus cos plus 1 over cos. Huh? Wait, hang on. I see. So yeah, minus 1 over this would become actually the, well, we know from previously it's the natural log of tan, oh no, I run out of space, plus 1 over cos. So you can bring this 1 over cos cubed to the other side, so you have 2 of 1 over cube dx equals sine over cos squared plus natural log of that whole tan plus secant. Okay. That was a bit complicated. So essentially, this whole, this whole thing then becomes 1/2 of, can I even, so 25 times tan theta secant theta minus sine theta. Well, I guess it would be another 1/2 of tan theta secant theta minus 1/2 of the natural log of tan tan theta plus secant theta. Wow. So those you can simplify these two terms. Have I got that correct? That's, yeah, I've gotten that correct. Plus c, you know, which then you have to simplify back to the original term. So tan theta is that we know from the relation. Then secant theta is square root of x squared plus 25 over 5. So you end up with 25 over 2 of x times square root of x squared plus 25 over 5 minus the natural log of x plus square root of x squared plus 25 over 5 plus c. Yeah, that's you know, that was the first one that I kind of just actually gave up, but yeah, very difficult. That one's very difficult, I would say. Next one doesn't seem any simpler, so let's give it a shot then. Let's do some small talk while we're here. So what else have been done? Recently, yeah, I've been not really watching any anime or manga really, but there's one manga I really want to catch back up. It's called Murcielago. I don't know if anyone heard. It's really, what's the word? Raunchy. There's a lot of yeah. It's about a government hired woman that's also a serial killer, but she yes, she also have indulged in cardinal sins. It was the best way I can put it. A lot in the manga, and there's a lot of blood, a lot of gore, but I don't know. I found that quite recent, not quite recent, quite a whiles back, but I haven't seen any new translation up, so I don't know if it's officially translated anywhere, but yeah, I don't know, I'm not sure. I have to think about it. So this next one, cos x times 4 minus sine square x. Once again, it's some can we once again use something similar to before? So if we let 4 minus, wait, hang on, this time it's actually already in this form. So 4 minus sine doesn't really mean anything. I guess it's also 3 plus cos square x. Right, what is, okay, let's if this fails, I'm not getting a punishment. But so let's just say, because I have no confidence in this. Let's say, what if we just let this happen? What do we get? So u square equals 4 minus sine square x. Then 2u du equals minus 2. Yeah, because sine doesn't differentiate well. Okay, yeah, I know. I knew that. Totally. Just so I knew this one would work. So what would work is the question. So if we just let u equals sine, du would be cos du. Would that simplify? I think it would. But then, is square root of 4 minus u square particularly easy to solve? Let's see. I guess you will have to use chain. Am I dumb? I might be dumb. Hang on. For alright, fine, I'll do another exercise because I don't really I'm like kind of sure about this, but at the same time, if I want to be really sure, I have to look it up, and looking it up means I have to do another exercise, so you might as well get this over with. Oh no, why is it? Why? Okay, fine. Alright, make sure I stretch. 1, 2. Oh, I don't really have space. 3. 4. Ow. 1 more. 5. Ow. And I forgot to switch music that time, but that's fine. It didn't take too long. Alright. So how would one solve this? X square root of 4 minus sine. There are places that tells me the actual the solution, but it doesn't tell you how you get there, and it's not always exactly the same as what you're looking at. Yeah, there's people that look up cos x over square root of 4 minus sine square x. We're slightly different from what we have here. Wait, hang on. I don't even need to. What I need to look up is how would you solve x square root of 4 minus x squared. They say to replace your x with 2 sine theta, which just gives me this form again. Alright, so I guess what I could have done is for some reason, instead of letting, maybe that'll work. Let's see. Let's just try it. Instead of doing that, we say sine of x is equal to somehow 4 sine of theta. So x equals 4 theta? No, it's not that simple. No, so x would be arc sine of 4 sine theta. Yeah. So in this case, cos of x dx equals 4 cos theta d theta. So dx is let me try this out. Dx is 4 cos theta over cos x d theta. So then you would have the cos here gets cancelled out by this, so instead you have 4 cos theta at the front over 4 minus 4 cos sine square theta. Nope. Hang on. I just realized that's a square instead of, so this should have been 2's. That one as well. And then when you square it becomes a 4. So yeah. So d theta. Then you can take the 4 out. 2 times the 2 in the square root here. Cos theta, 1 minus sine square theta, which is cos square theta, square rooted. So this is another cos theta, which gives you cos square theta d theta, which we've done before, is 4 times square root of cos 2 theta plus 1 d theta, which is 4 times 1/2 of sine 2 theta I just realised converting it back would be very annoying. Plus theta. I'm sure there's a better way to solve this. There has to be. Plus c. But because because what we're having now is stupid, because okay, hang on. So somehow we have, like, say, if we want to draw something similar to a diagram, we have something like we have theta x square root of 4 minus x square Wait, hang on, let's not do x, because x is already been... not x, something that's not x. A. 4 minus a square. And 2. So... yeah, sine... hang on. Blah 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 blah. So yeah, sine theta. No. Yeah, it's even dumber than this, because I was thinking maybe I can draw another x here, but no, this would be sine x, and this is 2, and this is 4 minus sine square x, meaning, yeah, sine theta is sine theta is sine x over 2, which we've established before, but cos theta is sine x, is square root of 4 minus sine square x over 2, which I guess we can figure out with just this relation and the circular relation. What's the sine square plus cos square equals 1 relation actually called? I don't remember. Anyway, half of sine 2x, that's sine x times cosine x, by the way. So it's 4 times sine x times cosine x. So sine x, no, sine theta times cosine theta, my bad, times, so which is sine x times 4 minus sine square x over 4 plus theta, which is at this point is the arc sine of sine x over 2. Can that be simplified to like x or something, x over 2 or something? I'm looking at stuff up anyway, so maybe, what is the arc sine of sine x over 2? I don't think it's necessarily just x over 2 because of how sine works. Alright. Let me look up Wolfram Alpha. Arc sine of sine x over 2 is doesn't simplify for us. Great, is the arc cosecant of 2 arc cosecant of x. No, that doesn't help. Yeah, sine is a periodic function. Anyway, I'm just gonna leave it at that. Plus c. You know, you can simplify this a bit with take out the 4, but yeah, let's just leave it at that. Alright. That's another question done. That took forever. Let's see how far we can keep going. Boom, 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 boom. Are you sick of this song yet? I'm not. An absolute banger, I tell you. Right, 13. What is 13? 13 is something. Seems to be we're moving to something different, hopefully. 1 over x squared minus x plus 1 dx. So, from this, I think we're going to have to use partial, what's the actual name? Partial fraction decomposition, which I guess is a bit higher, slightly more difficult technique. Wait, no, but I can't really. Is that? Can you factorize this into anything? I don't think so. Okay, so let's see here. No, I can't really factorize this, so it would just go back to itself. Okay, maybe for a future one. If this was 2x, then that would have been easier because that would just be x minus 1 squared, I guess. X minus no. Yeah, no. Okay. I swear to God, if this is another substitute the trigonometry identity in here, right, okay, let's think about how we can simplify this. So x squared, x minus 1, it can also be x. So if we have x minus 1 squared plus x, right? Maybe. I kind of. So there's a complete the square method where you can x minus 1 squared, that's x squared minus 2x plus 1, which then you can add an x here. So that's something. Then I guess you can multiply this by x minus 1 squared minus x, I guess. Maybe? Is that making it more difficult? What if we multiply this by x minus 1 squared minus x over x minus 1 squared minus x? Hang on, let me... That looks like an extra x there. Let me use a dot instead. Yeah. So that will give you x minus 1 squared minus x over... I'm probably doing this very wrong because this would be power 4 minus x squared. Wait, yeah, that doesn't help at all. Ha! Okay, more exercise. Come on, bring it. I'm stupid. I did it the wrong. This one is because I was slightly confident to doing the wrong way. If I preface it that I know it was wrong, then I wouldn't have to do this 5 sit-ups. This is gonna be quick side. I'm not gonna put on the music anyway. Right. Ow! I hit my head. Ow! 1, 2, 3, 4, 5. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, think I should just rename the stream to just me exercising 100 times and also looking up how to solve 100 integrals instead of alright. But you know, guys, we're learning, so once we learn a bit more, maybe we can one day solve one of these equations ourselves without needing any help. It's like any other puzzle game, you know? Sometimes you're stuck, you need a little bit of guidance, and then you find some similar puzzles in the future. And I see. I was doing it. I was basically correct, but I was going about the wrong way. Instead of taking out the x, what I should be doing is taking out the unit factor. I forgot about that part. So this becomes x minus a half. So that will give you x squared minus x plus 1/4. So you need to add 3/4 here. Sorry, squared. So if we let u equals x minus a half, don't need to multiply it by anything. This just becomes 1 over u squared plus 3/4 dx. I see. It uses one of the formulas on top of my head that I've neglected to look at for a while. So okay, we want to do another second substitution here. So let's turn this 3/4 into 1 by, say, that's equal to 1 over 3/4 1 plus 4/3 u square du. Oh, this is u as well. Then if we let t equals 2 over root 3 of u, then you would have, you need to multiply du divide by root 3 over 2 times d3 over 2, so root 3 over 2 times this factor at the bottom we multiply 4/3 integral of 1 over 1 plus t squared dt. We should, just for future sake, also write down that in order to get back to x is u plus a half, which is no, what am I doing? So t is 2/3 2 over, which is also 2 over root 3 of x minus a half, which is 2 root 3 x minus 1 over root 3. I guess I was squaring it afterwards. So here we go back to black. Here we have 2 over root 3 integral. Well, I don't need integral. It will be the arc tan of t plus c, which would be 2 root 3 arc tan of 2x minus 1 over root 3 plus c. Okay, I see. That's so, yeah, that's how you'd complete that square. Okay, now I remember. Well, I relearned it, so hopefully I can apply that if it ever shows up again. Where are we now? Number 14. It's been 3 hours since I started, 2.5. 14. Oh, right. What is 14? 14 is the integral of, my god, can you believe it, is x square root of x squared plus x plus 1. Now, I've done, I looked up the square root of some, but that was a difference of 2 squares, and in that case you can use trigonometry identification. So in this case, maybe we should complete the square, so then it becomes a difference of 2 squares. Yeah, that sounds fair. So square root of is this the exact same? No, it's slightly different. So we want x plus a half squared here. That'll be x squared plus x plus 1/4. So we need to add another 3/4 here. Or maybe it would be easier to write this as root 3 over 2 squared. So now we have, well, it's not the difference of 2 squares, but the sums of 2 squares. Would that be a problem? No. Right? No. Possibly not, I would say. If we let x plus a half equal root 3 over 2. Now here I guess we want to put some trigonometry identification, so either sine, tangent. I don't think sine would work because sine is always, you have 1 minus sine gives you cos, but remember 1 plus tan does give you secant, or yes, secant. So, or we can use cotangent. 1 plus cotangent gives you cosecant, I guess. Let's do this tan. Let's do tan of theta. Then dx equals root 3 over 2 times secant square theta d theta. So this gives you root 3 over 2 secant squared from the derivative square root of let's take out the root 3 over 2 times the square root of tangent squared theta plus 1 d theta, and this is equal to secant. Secant, yes, because there's sine and sine and a cosine over cosine equals to 1 over cosine, so squared, which is, so we have 3/4 of secant to the power of 3 d3, and we've done this before. Can I bring that back up? I'll just bring that back up. We've done this before. This might speed things up. So it's not cheating, because I've done it already. Totally. If I can find that video again, where is it? One over secant. Just tell me, just no, not 1 over cos to the 3. Apparently there's also a way to solve it by... that's just the only way. Solve it by parts. Hey, and when you know, I remember, I totally didn't look it up, that this equals half of what was it? Without cheating or looking it up, I remember this is half of tan theta secant theta plus the natural log of tan theta plus secant theta. Yeah, I totally remember that off my heart. Wow, how good am I? So okay, so tan. Right, let's do some trigonometry here. Tan is equal to. Let's use different colors to highlight this. Let tan is equals to x plus a half times over times 2 over root 3, which is root 3. 2x plus 1 over root 3. And I'll run out of space. Tan squared, I'll just write that as t. Tan squared is 2x squared plus 1. Well, it's x plus half squared, which we know is x squared plus x plus a half plus squared times 4 over 3. So it's 4/3 of x squared plus x plus 1/4. So it's 1/3 x squared plus x. Oh no. 4x squared plus 4x plus 1 to simplify a little. So we know that tan squared plus 1 is secant, so secant square is over this plus 1. So it'll be 4x plus 4x plus 4 over 3. Ah. That's, yeah, am I doing this? Is that correct? 4/3, 1/3, 4/3. I don't know, it seems a bit wrong to me. Am I correct in saying it's 4/3 of x squared plus x plus 1? No, because this is what I got up here, right? Yeah. Right. Yeah, maybe. I'm getting a headache from this. So secant is the square root of that. So what I'm getting at the end is 3/8 times, oh dear, 2x plus 1 over root 3 times 2 over root 3 square root of x squared plus x plus 1. Which I guess, yeah, we can simplify that out. Plus the natural log of 2x plus 1 over root 3 plus 2 over root 3 square root of x squared plus x plus 1 plus c. That becomes a third. You know what? I'm not going to simplify this any further. You can simplify this further if you want, but that's it. I'm getting lazy, so that's where we'll stop. That one. Hey, look at that. We've done something. The only thing I had to look up was what the secant. I mean, I didn't look up anything. I just remember that. Let's just assume we have. I'm erasing all this. Let's just assume we still have all these answers written down. So if I've seen them before, I can use them unless I forgot about them. All right, 15. What is 15? 15 is 5x plus 31. Wowee, over 3x squared. My God, minus 4x plus 11. Yeah, you know, for that last one, I'm not even certain if I got anything right, but it is what it is. Let's see. So I'm saying is that if we can factorize a split in the bottom. I don't think so. Because if I can factorize a bit in the bottom, I can solve this by the partial fraction decomposition, but it looks like I need to solve this by doing something similar, doing the square substitution. Maybe. So let's have a think. 3x squared minus 4x. But that's me thinking, right? So thinking doesn't really count into punishment. So this is 3x squared minus 4/3 plus 11 over 3. Which is 3 x minus 2/3 squared, which gives you plus 4/3. So you need to add another 7. So it's 3x minus 2/3 squared plus 7. Okay. So if we let u equals x minus 2/3, so in the top bit you would have u plus 2/3 of, so 5/3 plus 30. Oh my god. So 5 u plus 10/3 plus 31. I don't know what that is, but let's just put a bracket there so we know it's the one number. It's 103 over 3. Over 3 u squared plus 7. du. So you split this into 2. The units on the top and the units at the bottom, you can probably simplify that into a arctangent. U over u squared plus something. Why does that sound so familiar? So I guess it's a natural log. I just need to remember the actual definition for the integral natural log. That doesn't count, right? That's part. If I can have these cheat functions up there, I can look up the natural log integral as well. Man, what they don't tell you about streaming is how tired your throat gets. All right. I guess it's integral derivative of natural log. So I found an image that says if you, so So it seems like the definition you can derive that if you have an integral of a function derivative over its function, you can no, take that away. That the integration becomes the natural log of the function. Alright, so on the left side can somehow be turned into one of these times a factor. So what is the integration? So what is the derivative of, let's get rid of that. So the derivative of 3u squared plus 7 is 6u. So this equals integral of, so it needs to be 6 on top, so we'll times it by 6u over 3u squared plus 7 du plus integral of 103 over 3 times 1 over u square, no, yeah, take out the 3, take out the 3 here, so it would be 9. 1 over u square plus 7 over 3, and this no, I want it to be 1 here. Okay, yeah. So, my bad. 3/7. I guess the 7 would be here as well. Hang on, sorry. Divide. This is getting a bit confusing. 103 over times 1 over 3u squared. I can turn that into 1 plus something by dividing the whole thing is by 7. That means I have to multiply it by the top by 7. Yeah, 7 over 1 plus 3 over 7 u square du. So we can once again use a second substitution. 3 over 7u square equals t, well, t equals root 3 over 7 u, which means dt equals that times du, and then I have to write that out. So this equals 5/6 natural log of 3u squared plus 7, because the bottom is the top is the derivative of the bottom, plus let's just say 103 times 7 over 3 integral of 1 over 1 plus t square times the square root of 3 over 7 dt, which is 5/6 natural log of u square is 3 squared plus 7 is just this top bit, right? So 3x squared minus 4x plus 11 plus 103 square root of 7 over 3. And what is the 1 over 1 plus its arctan? Yeah. T, which is root 3 over 7 of x minus 2/3. So it's x. Hang on. No. Yeah. Root 3 times root 7. So root 21. Or, more succinctly, root 3x minus. Ah, fuck, I forgot what I wrote down. 2. Yeah, 2 over root 7. No. 2 root 3. Oh, alternatively this is 3x minus 2 over root 21. There we go. If you're wondering why I'm starting to sound more like an ASMR, it's my throat is getting tired from just talking, but that's good. Maybe we'll pretend this is closer to a library with music blasting in the back, but that's 15, right? Maybe we can get to 20 today. Also, I've solved the last 2 without having to do any exercise. Without searching up natural log does not count, okay? And alright, where were we? That was 15, wasn't it? 16. X to the 4 plus 1 over x squared plus 2 dx. Now, how would one solve this? So my instinct is to turn the bottom into a single variable, so something's like u squared instead of whatever we have there, so that you can just separate the upper part into 2 terms. You can separate the whole thing into 2 terms. Right, how would I go about that? Maybe it's easier if I just solve this in 2 parts instead of trying to force them together. Because this right part, it can just become God, I forgot the let's see. It's 2 plus x squared dx. So on this side we can use the u equals hang on, 2, it's, if I take out the half, it becomes 1 plus half x squared. So we want u to equal x over root 2. So that x squared over 2 becomes u squared. Yeah. So dx is root 2 dx. So we'll take off the half. So this bit is half square root of 2. No, my bad. Root 2, because this is times root 2 plus u squared du, which is, I'm solving them by parts so it looks a bit weird. Natural log, nope, arctan of u, which is x over root 2 dx. Oh. So on this side, let's say, let's highlight this as green, so that green applied for that. Let's highlight the spot with blue so we know what we're doing here. So I guess we can just say, let's call it v equals, well, v square equals x square plus 2. So 2v dv equals 2x dx. dx is therefore v over x dv. So top bit becomes x, oh no, I just realized what I've done. Yeah, I'll write a reminder for myself. This is 1 over root 2 arctan of x over root 2. Then I can delete this so I can write this out properly. Oops. Delete this. V squared minus 2 squared. Is this really easier to do? I don't think so. V over v squared. I guess it's easier to do. Plus dv? No, times v over x dv. And then this bit is on top arctan of x over root 2. This bit, top bit, is v to the 4. Ah, no. I'm stupid because the x here doesn't really go away, does it? So that substitution is wrong. Okay. Okay, I'll omit that. That bit might have been an error on my part. Should I do exercise for that? Maybe afterwards. Let me focus on this bit. If I can solve it now, I neglect the exercise because I am smart. Maybe I was on the right ballpark, but not entirely. Alright, I'll do an exercise and then look up how to solve this left bit. Alright. Bring out the wheel. Spin it. 5 more strip. Okay. 1, 2, 3, 4, 5. Ow. Okay. Back to your usually scheduled program. Alright, so how the fuck do we solve this? X squared plus 2. I see. So what you want to do, I guess, is long division with x. So x. There's something I haven't done in quite some time, but I'll give it a shot. So x quarter, you can divide. If we want to divide that. No, hang on. That's not how you write it. x4. That's not how you write it either. X squared plus 2. So x squared, you take away x squared plus 2, x squared. Oh, it's 4. I think you want to write it like this. 2 2x squared. I'm going to leave a gap for x to the 3, just in case you have something left over. So minus 2x squared. So minus 2. That will give you minus 2x squared minus 4, which will give you 4. So then you can say x to the 4 over x squared plus 2 equals x squared minus 2 plus 4 over x squared plus 2. I see. So it was, you want to simplify this first and then put it over on the other side. So basically we plus 4 on this side turns out from a 1 to a 5, therefore we just put a 5 in the front here. So that is, well, don't do it like that, that's misleading, but equals x squared minus 2 plus 5 times root 2 arc tan of x over root 2, which gives you x over 3, x cubed over 3 minus 2x plus 5 over 2 root 2 arc tan of x over root 2 plus c. And that is how you solve this one. Okay. Number 17. Integral of 1 over, and I could cry because it's 1 over 5 plus 4 cosine of theta, d theta. So I want to cry. This is interesting. Let's see. So the 1 on the top could be turned into sine squared plus cos squared. The cos itself, you can separate that into double angle, or half angle, I guess. Like, I don't know. Let's see. Let's just try and use a half angle. So, what was it? So I know cos 2 theta is cos cos square minus sine square of theta. So cos theta is cos theta over 2 minus sine theta over 2 squared. Okay. Would that work, or would I want to use the other version of it, which is like oh, where's my pen? Because the other version of this is let's turn it to sine. So it's cos square is 1. So cos square minus sine square. I can't remember the other ones. So I know cos square plus sine square is 1. So cos square is 1 minus sine square. It's 1 minus 2 sine square. So cos. So let's say this is 1 over 5 plus 4 times 1 minus 2 sine theta over 2 squared. So 1 over 9 minus 2 sine square theta over 2. No, that's not right. I think what I should do is make the bottom, get rid of the unit, and so cos theta is cos square minus sine square. 1 is cos square plus sine square. Then you have here 1 over 5 times cos square plus 4 times cos square. So 9 cos theta over 2 squared. So then you take the difference, minus sine plus, so minus sine square. Okay. Then you can divide times this by well, divide each side by cos square, maybe. Or times it by secant squared. That gives you secant is over 2 over 9 minus 10, because then we can get a natural log some way. No, we can use u equals 10 du is secant squared of half d theta. Then 2 d theta over 9 minus u square, and I keep forgetting how this actually factorizes, but if we take the 9 out, then you have 1 over 1 minus u square over 9, which you can then say, these should be du by the way. You can then do t equals u over 3, so dt is du over 3 times it back by 3. Yeah, okay. Something like this. 1 minus t square, which is 1 minus, what is it? Is it a natural, wait, Did I make a mistake somehow, or is there something yeah, I did make a mistake. It's 5 sine squared plus, it should be plus. Which is arctan t, which is u of 3, which is tan theta over 2 over 3. Plus c. Alright. God, my throat is dying. I think I'm gonna stop after 20, so. And then I'll stream again some other day. Alright, 18. Square root of x over 1 plus x dx. Alright, let's see. Alright, hypothesis. What if u equals root x? What happens then? U square is x, so 2u du equals dx. So dx, then you have u over 1 plus u square times 2u du. So it made it more complicated, right? Is that divide or is that over? Yeah, it's over. Yeah, so not like that. Well, maybe. Maybe like that, because this feels easier, maybe. Maybe. U square 1 plus U square. If we let one I think I've done this before and it doesn't work, so I don't anticipate it to work. I think that brings a square root back into the equation, so no. Feels like I can do another identity, like trigonometry. If instead of u is square root of x, we said tan of square root of x, no, tan theta is square root of x, maybe. Tan or sine or cos, sine. Let's try sine. Cos, actually it will be square on this side. This would be t sine theta squared cos theta. Which is cos squared which is tan secant. Did we do this before? Isn't this like just secant? Let me look it up. It is. It's just secant. I'm scared how well that worked out. So cos 2. So if you remember, sine square plus cos square equals 1. Sine cos equals square root of 1 minus sine squared over 2. No. Just that. So square root. No, 1. No. 2 over square root 1 minus x. Oh wow, look at that. That doesn't feel right, but that's what I got, so yeah, wowee. Leave a comment if I'm completely wrong. Cos x 4 minus sine square x. That's the next one. It seems awfully familiar. It is. It's the other one, but instead of it's at the top, it's at the bottom. So we can use Newton, cool. Is that one of the func identities? It is, it's arc sine. Take it. I'll just do it's 1 over 2. Arc sine of u over 2. Let's see. Which is arc sine of sine x over 2. Wow, that felt dangerously quick. So, last one before my throat completely gives up on me. Do. 20 cos 2x over cos x dx. This is So cos x to x is cos square minus sine square. Now, which of the identity will give me the easiest time here? Tangent, maybe? No. Secant, maybe? No. Ah, okay. Yeah. Science, that doesn't really work. So 1. So it's sine square minus cos. No. It's cos square minus sine square. Which means this. 2 cos square minus 1. Simplifies this. So 2 cos x. Well, cos of x minus secant of x dx. So we know the left part, that's really easy. It's just sine of x. Secant, I remember. Let me look this up. I remember. It was that thing where you timed it by. It was like secant of x times secant of x plus tan x over secant of x plus tan x, which gives you secant square, which is the integral of tan square, and secant tan square, which is the derivative, of secant square. So it's just a natural log of this, minus the natural log of secant x plus tan x. See? We've learned something from the 20 questions we've done today. Hey! That's 20. I think I'm gonna take a break for here. Come back to this another day. We still got 80 to go. 80! But yeah, maybe I'll stream something else in the middle. But yeah, I hope that was edutaining. That was, put that in the background while you play. Maybe hopefully you learned something about it. I do want to stream a few more things. Definitely when Baldur's Gate comes out, I want to stream it. Maybe a few other games that if I ever feel like playing it, I would stream it. There's a lot of games I want to stream, but I've already played it, so it would just be me playing without reacting to anything. So I don't know. In the future videos, I got a few ideas coming up, but I'll leave that as a surprise. Maybe you see as they come out. Maybe I'll move the Pathfinder game from videos to stream as well, because the videos editing is getting a little bit annoying, and streaming seems like honestly an easier solution. Now that I got this kind of set up, semi-sorted, maybe it'll be a lot easier for me to do that. So I don't know. Alright, I'm going to go rest now, so I haven't talked in like this much in like a couple months or so. maybe that's why my throat's losing stamina. So maybe in the future I can do longer streams. But for now, I bid you adieu.